All right, section 7.4 is an introduction to probability. And the first thing we're going to talk about is how to use something called a tree diagram. It says here, in our daily conversations, we often talk about the likelihood or the probability of a given result occurring. For example, the chance of thunder showers is 70%. What are the odds that the New Orleans Saints will go to the Super Bowl? What is the probability that you will finish cleaning your room today? It says each of these happenings, thunder showers, the New Orleans Saints playing the Super Bowl, cleaning in your room today, is called an experiment. And the possible results of an experiment are what we call outcomes. For example, if we flip a coin, that's an experiment. And the possible outcomes are either heads or tails. If you flip a coin, you're either going to land on heads or you're going to land on tails. And it says one way to picture the outcomes of an experiment is to draw a tree diagram. Each outcome is shown on a separate branch. For example, the outcomes of flipping a coin are either heads or tails. Okay, so let me scroll down a little bit. Okay, so we're going to draw a tree diagram for tossing a coin twice. Then we're going to use the diagram to find the number of possible outcomes. Okay, so we're going to flip a coin 2 times. The first time we flip a coin, that coin can either land on heads or tails. Now, the second time we flip that coin can also either land on heads or tails. So what this means is that if we flip the coin the first time, we could have landed on heads. Second time, we also could have landed on heads. Or we could have had heads and then tails. Or perhaps we would have had tails and then heads. Or it could have been possible that we got tails on both. So we have a total of 4 possible outcomes. Okay. The next part here says, let's draw a tree diagram for tossing a coin 3 times, and then we'll use the diagram to find the number of possible outcomes. Okay, so let's think about that. We could have landed on heads or tails. Second time, heads or tails. And the third time, heads or tails, heads or tails, heads or tails, or finally, heads or tails. So again, I want you to think about that for a moment. In doing this, we could have had heads, 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 or heads, heads and tails, or heads, tails and heads, or heads, tails, or tails, or tails, heads and heads, or tails, heads and tails, or tails, tails and heads, or finally all 3 could have been tails. If we look at the number of outcomes here, we have a total of 8. All right. The next part here says, let's draw a tree diagram for an experiment consisting of rolling a die and then tossing a coin. Well, when you have a die, it sort of looks like this, right? You got a 1 here, and maybe a 1, 2, 3, and maybe a 1, 2, 3, 4. But essentially, we have 6 sides to it, right? So we either have the possibility of getting a 1, 2, 3, 4, 5, or 6. So when I roll that die, 2, 3, 4, 5, 6, I'm either going to get a 1, a 2, a 3, a 4, a 5, or 6. After we roll our die, we're then going to toss a coin. So if I get a 1 and I flip my coin, I can get heads or tails. Same thing for my 2. Same thing for my 3, my 4, my 5, or my 6. So we can get a 1 and a heads, or 1 and a tails, 2 and a heads, 2 and a tails, 3 and a heads, 3 and a tails, 4 and a heads, 4 and a tails, 5 and a heads, 5 and a tails, or 6 and a heads and 6 and a tails. We have a total of 12 possibilities there. Okay, so the next part here says the probability of an event. It says the number of ways that event can occur divided by the number of possible outcomes. Okay, so here it says if a coin is tossed twice, find the probability of tossing a heads on the first and then I get a heads on the second toss. Okay, well, if we scroll back to when we were doing this earlier, let's see, here we go. When we flipped a coin twice, these were our possibilities. So I know I have a total of 4 possibilities. So I'm going to come down over here. The number of possibilities I can get is 4. What I want to know is out of those 4, how many of them have heads and then another heads? So if I scroll back up, only one of them had a heads and a heads. So when I come back down here, I'm going to say my probability is 1 out of 4. Okay. The next part says if a die is rolled 1 time, find the probability of rolling a 3 or a 4. Remember, in rolling a dice, we have 1, 2, 3, 4, 5, 6 possibilities. My possibilities here are 6. How many of those numbers are a 3 or a 4? 2 of them are. I can reduce that fraction to 1/3, so I'll go ahead and do that. The next part says if a die is rolled 1 time, again, I have 6 possibilities. These are my 6. What is the probability that the outcome is less than 4? Well, 1, 2, 3 of my numbers are less than 4. That fraction reduces to 1/2. Continuing with 7.4 in probability, the next problem says find the probability of choosing a red marble from a box containing 1 red, 1 yellow, 2 blue, 4 green marbles. What I'd like to do first is I'd like to figure out, number 1, the total number of marbles I have. So I'm going to add up my marbles: 1 red, 1 yellow, 2 blue, 4 green. I have a total of 8 marbles, okay? Now, we're looking for the probability of red. How many red marbles do we have? 1 out of 8. The next part says find the probability of choosing a blue marble. Well, there's 2 blue out of the 8. That reduces to 1/4. Now we want blue or green. Well, we have 2 blue, 4 green. That's a total of 6. 6 out of the 8 is 3/4. And then finally it says find the probability of choosing a red or a yellow. There's 1 red, there's 1 yellow, so that's 2 out of the 8, which is also 1/4. Okay. The next part here says, suppose the spinner shown is spun once. Find the probability of each event. Okay, so if you notice, we have a total of 3 possibilities. It can either be a 1, 2, or 3. So number 19 says the result of the spin is a 2. Well, there's only 1 2, so that's 1 out of 3. Number 20 says the result of the spin is a 3. Well, there's only 1 3, so that's also 1 out of 3. Now 21 says the result of the spin is either a 1, 2, or a 3. There's 1 1, there's 1 2, there's 1 3. So that's 3 out of 3 or 1. 22 says the result of the spin is not 3. Well, number 1 is not 3, number 2 is not 3, so we have a 2/3 chance of that happening. Number 23 says the result of the spin is an odd number. Well, both 1 and 3 are odd. There are 2 odd numbers, 2/3. And then number 24 says the result of the spin is an even number. Well, the only even number here is 2, so that's 1 out of 3. Okay. So the next part here says a new drug is being tested that's supposed to lower blood pressure. The drug was given to 200 individuals. So I know that there's my total number of outcomes, 200. It says 152 of those patients had a lower blood pressure. Well, that's what we want. 38 of them had a higher blood pressure. We don't want that. And 10 of them had no change. So the first question says, what's the probability that a patient had a higher blood pressure? Well, we had 38 out of 200, and I'm just going to reduce that fraction. I can divide them both by 2. That's 19 over 100. The next one says, what's the probability that a patient had either no change or a higher blood pressure? So that would be these two together. That's 48 out of 200. I can divide them both by 2. So that's 24 out of 100. I can divide them both by 2 again. That's 12 out of 50. I can divide them by 2 again. And that's 6 out of 25.